So when we started doing U substitutions, I mentioned that the U substitution technique comes from sort of doing the opposite of the chain rule. So the chain rule gave us a way of computing a derivative for a composition of functions, and the U substitution method gives us a way of integrating that sort of thing. And now integration by parts is a new integration technique that we're going to talk about. It's the last integration technique we have in this class. And this one comes from the product rule. So remember that because integration and differentiation are inverse processes in some sense, every rule that you have for differentiation is going to induce some corresponding rule in integration. So I want to try to demonstrate where this formula comes from. But it's essentially the cousin of the product rule. So let's say that we have two functions of x. So I'll call them u and v. And let's say that we compute the derivative of u times v. So we know by the product rule that this is u times v prime plus v times u prime. So now let's think about integrating both sides of this equation. So I'm going to integrate both sides of this equation with respect to x. So I would have the integral of a derivative, and that's equal to the integral of u times v prime dx plus the integral of v times u prime dx. So here I'm just integrating both sides of the above line with respect to x. Now, on the left side, I'm integrating the derivative of a function. So I'm taking the derivative and then finding an antiderivative, but that should just bring me back to the original. So this should just be u times v on the left side. Technically, I should have it up to a constant, but I'm not going to worry about that for now. So the left side ends up being u times v up to a constant. And now the right side, we don't have a fancy way of computing either of these integrals. Instead, I'm just going to abbreviate them in a specific way. So v prime dx is just another way of writing dv. So dv is v prime dx. And then similarly, the differential of u, the differential of u is the same thing as u prime dx. So we end up getting this equation from the product rule. And this is the formula that we're going to use, which I'll call integration by parts. Usually this formula is rewritten so that this integral appears on the other side. So normally we would subtract v du, or the integral of v du, from both sides. And the resulting equation that we get says that the integral of u dv is equal to u times v minus the integral of v du, if I just rearrange the equation up here. And this is the integration by parts equation. So what this allows you to do is, normally in integration by parts, we're trying to compute an integral that we have over here on the left side. And this formula is going to allow you to take an integral that involves u and turn it into an integral that involves du instead. So that's the way that I like to think about the integration by parts formula. It's useful because it allows you to take something inside of your integral that you don't like and replace it with a more complicated expression, but now you got to take a derivative of u instead. And that will hopefully make this integral a little bit easier to evaluate. So we'll see several examples of this, but before we got started on the notes, I thought it would be good to demonstrate where this equation